is our frame. So our first step, let's concentrate only on the reactions. Then let's calculate reactions. Take moments. Let's do it in this way. Take moments around RL to find RR. So we are going to apply the law of moment by saying anti-clockwise moments equals to clockwise moments. Remember, we are taking our moments around RL. Sorry. Then we are taking our moments around RL. Let me use yellow color to highlight RL. So from here, we are going to take our moments around RL. So it means all forces which are on the left of RL are anti-clockwise and forces which are on the right of RL are clockwise. But now when we check here, this is RL, we have 9 kilonewton, 32 kilonewton, 16 kilonewton. These forces are on the left. It means they are anti-clockwise forces. It means, let me start by 9 kilonewton. I will say 9 kilonewton multiplied by the distance of 3. So it will be like this. So let's go to the second one. It will be 32 kilonewton multiplied by the distance. Our distance here, it will be let me do it in this way. Our distance, okay, it will be 32 kilonewton multiplied by the distance. Our distance will be 9. It will be like this. 32 kilonewton multiplied by 32 kilonewton multiplied by the distance. Our distance will be 9. 9, then plus the last one, which is 16 kilonewton multiplied by distance. Our distance will be 3. 3 plus 3 plus 3, 12. So let's go to the total. Then we have RL. We are taking moments around RL to find RR. Now we will have RR multiplied by the distance. Our distance will be 1, 2, 3, 4, 5, 15 meters. Okay, let me say 15. Let's go to the second step. Then it will be 9 multiplied by 3. For the 9 multiplied by 3, let me do the calculator here. Calculator. Yeah, it will be like this. Let's go to the calculator. Then it will be 9 multiplied by 3. Our answer is 27. So it means here we have 27 kilonewton plus 32 multiplied by 9. 32 multiplied by 9, 32 multiplied by 9 equals to, let me repeat it again, 32 multiplied by 9 equals to 288. 288 kilonewton. Then plus, let's go through the last one, which is 16 multiplied by 12. Then let's go to the calculator. So 16 multiplied by 12 equals to 192. 192 kilonewton. So equals to 9. Let me do it in this way, RR 15 RR. So it will be, to the calculator, 192 plus 288 plus 27 equals to, then divide by 15. Our answer is, okay, 33.8. 33.8 kilonewton equals to RR. This is our RR. This is RR 33.8. Let's go to RL. Then for RL, we'll say take moments around RR to find RL. So let me do something like this. Let me underline here. Let me also change the color. Let me also change the color so that you can see. So if we're taking moments around RR, it means we have anti-clockwise moments equals to clockwise moment. Anti-clockwise moments equals to clockwise moments. It means now let's go to RR. On RR, we'll say all forces which are on the right of RR will be clockwise, and all forces which are on the right of RR will be anti. But here we have to be clear here. When I say all forces which are on the right are clockwise, not all of, but the one which is pointing upwards is going to be anti, just because it will be opposing these ones. So let's do it in this way. We have 16 kilonewton multiplied by 3, 16 kilonewton multiplied by, okay, let's do it in this way. Let me check. Then there are clockwise forces. So the anti-clockwise force, it will be RL. RL, let me change the color to be black. RL multiplied by 15 equals to 16 multiplied by 3, 16 kilonewton multiplied by 3 in this way, then plus 32 multiplied by 6, 32 kilonewton multiplied by 6, yeah, 32 multiplied by 6, okay, 32 kilonewton multiplied by 6 plus, let's go through the last one. It will be 9 multiplied by, it will be 9 multiplied by 1 2 3 4, or by 12, 9 kilonewton multiplied by 12. So this is 15 RL equals to 16 multiplied by 3 equals to 48. 48 kilo Newton plus 32 multiplied by 6, 192. 192 Newton plus 9 multiplied by 12. 9 multiplied by 12. 9 multiplied by 12. 108. This is 108 kilo Newton. So let's add 108 plus 192 plus 48 equals to 348 divided by 15. So 23,2. Our RL equals to 23,2. Let me check again. 23,2 kilo Newton. This is our RL, but we have to check. So upwards force must equals to downwards force. It means on the RR, this one, RR is 33,8 kilo Newton. So RL equals to 23, 23,2 kilo Newton. So let me put equal sign here, or equals to, it will be like this. So these are our answers. Let me go back. Okay, now we have RL, which is 23,2 and then 33,8. Let's check. We have 16 plus 32 plus 19. It's 16. Okay, let me do it like this. 16 plus 32 plus 9 equals to 57. Okay, these are our downwards forces. Let's go to the upwards force. The upwards force is 33,8 plus 23,2, 57. It means upwards force and downwards force are equal. Now let's go to the second step. Our second step will be like this. Step 2. On step 2 is to determine the value of P and the value of Q. It will be our Q, this one. If you can check on your question paper, you will see that this is P and Q. It's where we are going to start to design. But what you have to understand, you have to have the following information. You must understand that we have vertical component, VC. This is a vertical component, equals to force multiplied by sine. Okay, let me do it in this way. Force sine angle. Now here, just because in our frame we have 25, now we'll say 25 degrees. Then horizontal component equals to F multiplied by cos angle. This time we have a F multiplied by cos. 25. So you must also understand that the sum of horizontal component equals to 0 and the sum of vertical component equals to 0. Okay, let me explain something here. This is our force. In this force, we have vertical component, but we don't have a horizontal component just because it's going upwards. But you can also calculate the horizontal component using angle 0. Then you will end up getting 0 just because we don't have horizontal component on vertical. Even in this member, this one, um, this is horizontal component. We don't have vertical component on horizontal, but on P, just because this is an inclined member, it means we'll have vertical component and horizontal component. But for P, if we are talking about the sum of vertical component, we'll say P. Let's start to calculate the value of P. Here we'll say, we'll do it like this. I'm going to apply the force F cos F sum of vertical component equals to 0. It means um, it will be F sine